So the next topic that we have is applying the z-test when we wanted to check the difference of standard deviation for two different samples. So earlier, first thing that we studied was this z-test for single mean. Second thing that we studied is how do we apply this z-test for difference of means. So that means whenever you have two samples, so you wanted to check whether the two samples they come from the same population or not, or is there any difference between two different samples. And in the third case, which we'll study now, we'll study the z-test for difference of standard deviation. So in this case, we will compare the standard deviations for these two. And moreover, these tests, they are for the samples having sizes greater than equal to 30. So that means we are talking about large sample. For small sample, we have t-test and f-test for calculating of means and standard deviation. Okay. So now focusing here onto the z-test for difference of standard deviation. So let us see how do we define the test here in this case. So for that, if I assume two samples, so say this is sample 1 and this is sample 2, S2, right? According to that, if this sample has standard deviation S1 and this sample has standard deviation S2, so we wanted to check whether the two samples, so our aim is to check whether the two samples are from the same population or not. This is one task. Another thing we wanted to test is the sample standard deviation differ significantly or not. So this is first thing. Another thing that we could check from this test is whether the standard deviation of two samples differ significantly or not. So this we can check using this z-test for difference of standard deviation. So for that, first task would be to create a hypothesis. So what could be the hypothesis here? H0 would be the hypothesis, which is the null hypothesis, saying that the two samples taken from population, they have the standard deviation as equal. So we will say that the standard deviations do not differ significantly, or basically the standard deviations are significantly equal. So according to that, how can you define the this z statistics here? So it would be the difference in the standard deviations of these two samples, so that would be S1 minus S2 divided by the standard error. Now what is the standard error in this particular case? So that we shall see. So this thing would here in this case would be equal to sigma 1 square divided by 2n1 plus sigma 2 square divided by 2n2 square root. And again, this is this approximates to the standard normal distribution having mean as 0 and standard deviation as 1, right? And what are these sigma 1 and sigma 2? Sigma 1 and sigma 2, they are the standard deviations of the populations, and usually they are not known to us prior to solving the problem. So usually these are unknown, right? So what do we do if we do not know the values of the sigma 1 square and sigma 2 square? So for that, because we have large sample, large sample size. So therefore, in that case, we may use, instead of sigma 1, the value S1, which is the standard deviation for the sample, and instead of sigma 2, we may use S2, which is the standard deviation for sample. So instead of standard deviation for populations, we may use the standard deviation for samples. So leading to the formulation Z is equal to S1 minus S2 divided by square root of S1 square divided by 2n1 plus S2 square divided by 2n2. Now this thing is the standard error which we are not currently studying. How can we derive this thing for this particular distribution? That is out of the scope for this basic course. So let's target or focus here. How do we calculate that and see how this method works to determine the differences between the standard deviation for two different samples. So let us move on to the question here. So I have written down the question. It says that random samples drawn from two countries gave the following data relating the heights of adult males. So we have data from two countries. One is country A, another is country B, and they have listed you the mean height in inches of different adult males for country A and B. They have listed the standard deviation in inches for adult males of country A and B, and they have also given the number of samples present in country A and country B. So accordingly, this would be your first sample, this country B data would be your second sample. So this would be your x1 bar, this would be your x2 bar, the mean of first sample and the mean of second sample. Accordingly, this would be the standard deviation for the first sample, and this would be the standard deviation for the second sample, and accordingly this would be the number of elements which are present in the first sample, and this would be the number of elements present in the second sample. So here they are asking you about two things. One is there a is there the difference between means significant? So that means we have to check about the difference of means for these two samples. In the second part, they are asking, is there a difference between the standard deviations between these two samples or not? So let's get started with the solution. The first part, we already know how to do that. We have seen this thing yesterday, right? So first of all, you should write the given data and you should formulate your hypothesis. Your S1 is given to be 2.58, S2 is given to be 2.5, and then N1 is given to be 1000, and then N2 is given to be 1200. So now in the first case, you wanted to write down the hypothesis. So what could be your null hypothesis? Here you wanted to check the difference between means. So that means your null hypothesis would be that there is no difference between means of the two populations. These means are from the populations, right? So this would be your null hypothesis. In words, it would mean that the sample means do not differ significantly. Right? So corresponding to this, what could be your alternative hypothesis H1? It would be that there is a difference between the two means, right? So we may say that the sample means differ significantly in this case. So according to that, if you see what is your Z statistic in this particular case, so before doing that, let me also write down the level of significance. in the question they have not given you any level of significance here. So here we by our choice could take any level of significance. For the purpose right now I am taking this to be 5%. Okay, so after that let's move on to the third step where we would compute our Z statistic. Now Z statistics, when we wanted to check the difference between means, that is given by the formula x1 bar minus x2 bar divided by square root of s1 square by n1 plus s2 square by n2. Now you would say here we, instead of s1 and s2, we would have sigma 1 and sigma 2. Now because the sample size is large, therefore we may use, for large samples, we may use the value s1 instead of sigma 1, and we may use the value s2 instead of sigma 2, right? So let's move on and calculate this. So Z here would be, what is x1? x1 is 67.42, x2 is 67.25 divided by s1 is 2.58, so 2.58 whole square divided by n1 is 1000 plus s2 is 2.5, so 2.5 whole square divided by 1000. So you may use calculator in order to solve this number, right? So once you solve this, the value that you have with you is 1.56. You may check. So this is the value of Z calculated. So you may label this as Z calculated. After that, we move on to see the tabulated value. So Z tabulated at 5% level of significance and for two-tail test. Why two-tail test? Because if you look at your alternative hypothesis here, this is having inequality, right? So what would be this value? For that we would have to go back to the table.
Minus 1.96.
Yes, correct. For 5% level of significance and two-tail test, the value is minus 1.96 to plus 1.96. So Z tabulated value, that is equal to minus 1.96 to plus 1.96. So accordingly we will draw the distribution here with the straight lines. So here the critical values are starting on the positive side for plus 1.96 and on the negative side for minus 1.96. So this is your critical region here. Now let's, in the fifth step, compare the values. So your Z calculated value is how much? 1.56. 1.56, which is less than 1.96, right? Which is the Z tabulated value. So therefore your value 1.56 would be somewhere here. So it lies in the region of acceptance. So therefore in this case we will accept the null hypothesis. So therefore your hypothesis stating that the means of two different samples, they do not differ significantly, is correct. So we may conclude that, so last step, conclusion. There is no significant difference between the sample means. right? So this is for the first part. Now moving on to our second part. Here in the question, in the second part they are asking, is there any difference between the standard deviations of the two samples? So here we will use this particular formula in order to calculate the standard deviations. So let's start here. So first step again is to formulate the hypothesis. So the hypothesis here would change. Your null hypothesis in this case would be that there is no significant difference between the standard deviations. So in words we will say that there is no significant difference between sample standard deviations, right? So according to that, what would be your null hypothesis, alternative hypothesis? It would be the inequality hypothesis. So that means again two-tailed test. And again, we will check it for 5% level of significance. For 5% level of significance, the tabulated value is, we have just written it down, it is minus 1.96 to plus 1.96 according to the table at 5% level of significance with two-tailed test, right? So now let's calculate the Z statistic in this case. So the formula here is S1 minus this one, S1 minus S2 divided by square root of S1 square by 2n1 plus S2 square by 2n2. So let me write down the formula first. So we have S1 minus S2 divided by square root of S1 square by 2n1 plus S2 square by 2n2. So the values here which are given to you is 2.58 minus 2.5 divided by square root of what is S1 square, that would be 2.58 square divided by 2 into n1. n1 is 1000 plus 2.5 square divided by 2 into 1200, right? So all this data is given to you in the statement of the question. So now we have to compute this. So when you compute this value come out to be 1.03. Again, you may check this value. This is your Z calculated value. So next step is to compare these values. For that we will draw our distribution again. So this would be plus 1.96, this would be minus 1.96. This is your critical region. So now let's have a look where your value lies. The value is 1.03. 1.03 value would lie somewhere here, right? So it lie in the region of acceptance. Therefore, your Z calculated, which is 1.03, is less than 1.96, which is the Z tabulated value. Therefore, we will say H naught will be accepted in this case. If this is accepted, that means, what was the hypothesis? That means there is no significant difference between the sample standard deviation. So conclusion is that there is no significant difference between the standard deviations of the sample, right? So this is how you use the Z test in order to determine various test statistics for large samples. So in the next topics we shall learn about how to apply different tests for small samples.